Welcome back to Cycle 2, Week 2, Science, Boise Tutors. I'm going to be going through 2 experiments, the first being Mirage, number 24 in the Van Cleves Guide, and the second being number 26, Distortion. So for this first experiment, you can see my supplies here. Number 24, Mirage. We're going to determine why the sun's image is seen before sunrise and after sunset. So we will be using some modeling clay, a coin, a small bowl that we can see through, and a pitcher of water here. So the first thing we're going to do is we're going to take a walnut-sized piece of clay and press it into the center of this clear glass bowl. I decided to use a dollar coin in order to see it a little bit better. So we're going to press that coin into the middle of the bowl with the clay. And then we're going to place the bowl near the edge of my counter or a table. You can see that coin in the center, and we're just on the edge of that counter, and we're going to have our students slowly move backwards until the coin is just barely out of sight of that rim. So they're just going to move back until that coin, you can see it underneath that rim. And then you're going to have this helper slowly pour in your water. And as you can see, that coin has changed position, or it appears to have changed positions in the bowl. So the light from that coin changes the direction as it leaves the water and enters the air. This makes the coin appear to be at a different place. The change in direction of the light is called refraction. The Earth's atmosphere refracts light in a similar way, causing the image of the sun to appear before the actual sunrise is above the horizon at sunset and lingers after the sun moves below the horizon at sunset. So very interesting experiment. Let me know if you have any questions, and we'll move on to the next experiment. Our next experiment, number 26, Distortion in the Van Cleves Guide, we're going to be determining how the atmosphere affects the viewed shape of the sun. All right, we have our compass set to 1 inch, and we'll take it and spin it around our white paper to make our circle. So the shape of the circle becomes distorted. So the glass in the magnifying lens has a different thickness. As light passes through the lens, it changes directions. This change in the light's direction is called refraction. The thicker the lens is, the more the light is refracted, and the more distorted the circle is. The apparent flattening of the sun at dusk when it is near the horizon is due to the refraction of the light. It is near the when it is near the horizon. It's due to the refraction of light. The rays from the bottom edge of the sun are closer to the horizon and therefore travel through more of the Earth's atmosphere than the rays from the top edge of the sun. These rays bend toward the Earth as they travel through the thicker section of the atmosphere. The atmosphere, like the magnifying lens, changes the direction of the light passing through it, thus distorting the image seen. So a very fun experiment. Definitely let each of the students have a chance to practice moving that magnifying glass back and forth as you explain it, and use those science journals to record what they have found. Thank you so much, and we will see you next week.